So today we're talking about midsegments of a triangle. The definition of a midsegment is a segment that connects the midpoints of two sides of a triangle. So in this picture right here, it is just a line that connects both of the sides of the triangle at the very middle. So in this picture right here, what line would that be that connects both sides in the middle? Yeah, you're right. Line RS. Very good. Okay, so line RS right here is the line that connects both sides of the triangle at the very middle of that triangle. Now, the theorem tells us that if a segment connects the midpoints of two sides of a triangle, like RS, then the segment is parallel to and half of the length of the third side. So the first thing it tells me is that it's parallel to. So when we did the parallel lines unit, we saw that when we label something parallel, we put an arrow. So RS and DE are parallel. That's the first thing it tells me. And then second is that it's half of the third side. So the third side is technically the bottom side, the one that's not connected to the midsegment. So here, my bottom would be DE. So what it's telling me is that RS is half of DE, so I can write it as RS equals half of DE, or I could say 2 times RS equals DE. Now, if I made that a generic formula, it would be that the midsegment, and I'll call that MS, midsegment equals half of the bottom, or 2 times the midsegment equals the bottom. Okay, so let's look at some examples of those to make sure that we get how to do these. So in number 1, they give us DE. Is DE the midsegment or the bottom? The bottom. So to find the midsegment, I would do what to the bottom? Divide it by 2. So if I divide 20 by 2, AB equals 10. Okay, in number 2, we have, we're given the bottom piece again, PN. They want us to find LM, so what would I do to PN to find LM? Divide by 2, and so LM would equal 6. Okay, in 3, what part did they give us? The midsegment, so what would I do to find the bottom? Multiply by 2, so XY would equal 8. Okay, in 4, did they give me the midsegment or the bottom? Midsegment, so I'd do what to find PQ? Multiply by 2, so that would give me 30. So you got to make sure you know whether it gives you the midsegment or bottom, and then use that formula. Okay? So for 5 and 6, this has lots of little triangles within a triangle. So the first thing that they ask us about is the length of VX. So VX is right here. Is that a bottom or a midsegment there? It's a midsegment. Go ahead and turn your paper so that HG is at the bottom, and you can really see that XV is the mid-segment, to HG, which is the bottom. So they want me to find the mid-segment using the fact that 46 is the bottom. How would I find the mid-segment? Divide it by 2. So Vx would be 23. All right, next they asked me about HJ. So HJ is this piece right here. Is this a mid-segment or a bottom? A bottom. What is its mid-segment? Very good. WV, which is 27. So how would I find HJ then? 27 times 2. So that would give us 54. Now, the last thing that they asked me is the perimeter of triangle GHJ. So GHJ is this big triangle. I know this piece is 46, this piece is 54, and part of this piece is 35. What would this other part be right here? How do you know that? So because of these tick marks right here, we know that this length and this length is the same, so this would be 35. So to find the perimeter, we add all the sides together. We would do 46 plus 54 plus 35 and 35 is 70. This would give me 170 as my perimeter. Okay, does that make sense? It's a lot easier when you're able to turn your paper. I'm not really able to turn this, but if you'll turn your paper, the mid-segments are easier to see. So let's look at 6. So number 6, the first thing they asked me about is SE. Okay, is SE a bottom or a mid-segment? Is it a whole bottom though? It's only part. So how would I find just part of it? Yes? Very good. We know that because this and this has these tick marks that they're congruent. So if this whole length is 24, we divide that by 2, and SE would be 12. Okay? The second thing that they asked me about is DC. So DC is right here. Is that a mid-segment or a bottom? It's a what? Mid-segment. Okay, and what is its bottom? And ST's length is? 24. So how would I find this mid-segment? Divide it by 2, so this would be 12. Now, the last thing asked me about the perimeter of triangle CDE. So CDE is this triangle right here. So I have that this side is 6, this side is 12. How would I find EC? Because I'm not actually given EC here. What piece of the triangle is EC? Is it a bottom or a mid-segment? It's a mid-segment. What is its bottom? Not DC. SR. Turn your paper so you can see mid-segment and then the bottom. The bottom is flat. Okay? So how long is SR? Nope. SD is 8. This whole piece is 16. So if I wanted to find EC, I'd do what to that? Divide it by 2, and this would be 8. So to find the perimeter, I'd do 12 plus 8 plus 6. And so my perimeter would be 26. Okay, any questions so far? Okay, let's look at some that aren't just numbers. Okay, so in number 7, we are given the mid-segment and the bottom. Okay, so does it matter if I use mid-segment equals half of the bottom or 2 times mid-segment equals the bottom? Does it matter which one I use? No, we can use either. Which one would you rather do? Okay, we'll do 2 times mid-segment equals the bottom. So what would that look like? Very good. So we're going to multiply 2 times 5x is 10x equals 70. To get x by itself, we divide by 10, and x equals 7. Okay, and then I'm going to do number 9 because that one's a little more difficult. So for number 9, do we still want to do 2 times mid-segment equals bottom? Okay, so we're going to do 2 times, what is my mid-segment? 4x plus 7 equals my bottom, which is x squared plus 4x minus 14. It is 5x. I wrote 5x, but I said 4x. Okay? Then from here, we want to distribute our 2 out. This is going to give us 8x plus 14 equals x squared plus 5x minus 14. Next, we want to move our 8x over. So when I move it over, what happens to it? It becomes negative. So I get x squared plus 5x minus 8x, which would give me minus 3x. Okay, and then I move 14 over and it becomes negative. So I have 2 negative 14s, which gives me negative 28. Now, from here, I'm going to factor. It is a trinomial, so we factor by trinomial, and it is shortcut because this is 1. So what multiplies to give me negative 28 and adds to give me negative 3? And positive 4. Very good. So my x's are equal to the opposite of that. This minus 7 would become positive 7. This plus 4 would be a negative 4. Okay? Questions there? Okay. Let's flip to the back. Now, we've been talking about the coordinate plane, and we're going to talk about how to find a mid-segment in the coordinate plane. So the first thing that they asked me to do is to graph the points. So I'm going to graph R, which is 0, negative 3. So I'm going to go down 1, 2, 3, put a point. I'm going to label that R. And I'm going to graph S is 2, 3, so I'm going to go right 2 and up 3. And last, I'm going to graph T, which is 6, negative 1, so I'm going to go right 1, 2, 3, 4, 5, 6, and down 1. Okay, then connect all your points. Okay, number 2 asked me to find the midpoint of RS. Do y'all remember the formula for midpoint? x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So I'm going to label x1, y1, x2, y2. We're going to do 0 plus 2 divided by 2, and negative 3 plus 3 divided by 2. So this would give me 2 over 2, which is 1, and this would give me 0 over 2, which is 0. So one of my midpoints is going to be at at 1, 0, so I'm going to go right 1, and then I don't go up or down at all. So this is going to be A, because they told me to label it A. Then I'm going to find the midpoint of RT. So again, I'm going to do x1 plus x2, so 0 plus 6 divided by 2, and negative 3 plus negative 1 divided by 2. 6 divided by 2 is 3, and negative 4 divided by 2 is a negative 2. So now I'm going to go right 1, 2, 3, and down 2. I'm going to label that point B, and then I'm going to connect A and B. Okay, then it asked me to find the slope from A to B. So if this is A and this is B, do y'all remember the slope formula? y2 minus y1 over x2 minus x1. So that would give me negative 2 minus 0 over 3 minus 1. That would be negative 2 over 2, which is going to give me a negative 1. Okay? So from here, I got to scroll down, so I'm not going to be able to see any of this, so you're going to have to help me set up the rest.
You got really quiet.
It's my third. Okay. Let's look at number 8. So, can somebody help me set up the slope for ST? It's y2 minus y1 over x2 minus negative 1 minus 3 over 6 minus 2. So that gives me a negative 4 over a positive 4. And if I divide that, that's going to give me a negative 1. Okay, so if both of our slopes are a negative 1, what does that mean about the two lines? Yes, they're parallel. So we put yes, slopes are the same. Okay, now they want us to find the length of AB. So what can we equate length with? Distance. Okay, so we're going to have to plug into our distance formula. So again, I cannot see points A and B, so can someone set up that distance formula for me? Three minus 1 squared plus, is that right? Okay. Negative 2 minus 0 squared. So that's going to give me 3 minus 1 is 2, 2 squared is 4, plus negative 2 minus 0 is negative 2, negative 2 squared is 4. So this would be square root of 8. Then we would want to do the same and find the distance from S to T. So someone else set up the distance from S to T, the formula for me. 6 minus 2 squared minus 1 minus 3 squared. So that is 4. 4 squared is 16. And then this is also 4 squared, which is 16. So that's square root of 32. Now, I didn't actually work these out all the way. Is there a perfect square that comes out of 8? There's not a perfect square? We can break it down to 4 and 2, and we can take the square root of 4. So that's 2 square roots of 2. And what about 32? Is there a perfect square in that? 16 and 2. So the square root of 16 is 4 square roots of 2. So my last question wants to know, is AB half of ST? So AB was 2 square roots of 2. ST was 4 square roots of 2. So if I half 4 square roots of 2, is that going to equal 2 square roots of 2? Yes. So that is true. Okay. Now I want to talk about the triangle inequality theorem. So if you will look at your other page of notes, all that angle side relationships have to do, there's a whole lot of stuff up here that we could read and I can tell you what it means, but basically the side across from the angle or opposite of the angle always has a relationship with that angle and vice versa. So our longest side is always going to be across from our longest angle, and our smallest side is always going to be across from our smallest angle. So instead of filling in all of these notes up here, I'm just going to show you an example of that. Okay? So looking at number 1, which side is my smallest side on this triangle? BT, because it's 13. Okay? Now, what angle is opposite of that? A. Okay? So this is asking me to list the angles in order from smallest to largest. So I know angle A is the smallest because it's across from the smallest side. I would do the same thing. What's the next biggest side? 15. And that is across from what angle? B. So then angle B would come next. And so what is my largest angle then? Angle T, because it's across from my largest side. Is that pretty simple? Okay, let's try number 2. So which angle would be my smallest angle? Angle. Angle O. How do we know angle O is the smallest? It's across from my smallest side. Okay, and then what's the next biggest angle? Angle G, because it's across from 8. And so that means that angle H is my biggest. Is that pretty simple? Okay, so the next part is kind of doing it backwards. So now we're going to look at the angles and compare them to the sides. So number 4, which angle is my smallest? Angle A. So what side is it across from? HL. So HL would be the smallest side. Then which one comes next? 60, which is across from HA. So my biggest side would be AL. I didn't mean to put that angle at the very beginning. Okay, what about a number 5 when we're not given this last angle? What would we do here? Very good. We add these two together, which would give me 147, and then I'd subtract that from 180. So this piece would be 33. So what side, or which angle is my smallest? 33. What side is across from that angle? OL. So OL would be my smallest side. Then what else? OW would be next. And last would be LW. Yes, ma'am. It should be longest to shortest. I put it shortest to longest. Up here it said, list the sides in order from longest to shortest. I swapped them. Okay. Okay. Any questions on how to determine which side's the longest, which angle's the biggest? Okay. Well, what I need you to do is flip to the back of the page, and you do not have these notes, but I'm going to tell you what I need you to write down. Okay? So I want you to write this right here. Okay? The triangle inequality theorem tells me that if I add two sides of a triangle together, it should be bigger than that third side that I didn't add. So right here, these are examples of that. It's like saying if I add A and B, it should be bigger than C. If I add B and C together, it should be bigger than A. And if I was to add A and C together, it would be bigger than B. Okay? I told you you do not have these notes, so you needed to flip over on the back and write down what I just highlighted. Okay? Because the back is going to ask you about these things and you want to be able to do them. Okay? So if you will just watch these examples down here, I will show you how to figure out if these side lengths can make a triangle. So in number 1, if I just randomly labeled these A, B, and C, I would look to see if I added 2 of them, are they always bigger than the third side? So if I add 15 plus 12, is that going to be bigger than 9? It's not? Yes. 15 plus 12, what does that give me? 27. Is 27 bigger than 9? Yes. Okay, no question. 12 plus 9, is that bigger than 15? Okay. And what's the only 2 I haven't added together yet? 9 plus 15, is that going to be bigger than 12? Yes. So yes, all of these can be sides of a triangle. Okay, let's try number 2. So if I do 9 plus 20, is that going to be greater than 10? Yes. If I do 20 plus 10, is that going to be greater than 9? Okay, what about 9 plus 10? Is that greater than 20? No, so these could not be the sides of a triangle. Okay, does that make sense? That's what numbers 7 through 12 on that sheet ask you about. That's how you would do this. Okay, now on 13 through 18 on your sheet, they're going to be similar to these problems right here. And it says, describe the length possible for the third side. The way that you would find the length of the third side, it always has to be bigger than what our two sides added together always have to be bigger than the third side, right? So the way you would find it is you do 8 plus 12, that's 20. So our third side has to be smaller than 20. So I'm going to put x is less than 20, but then I also want to subtract those, which would give me 8. No, sorry, 12 minus 8, which gives me 4. Okay? Now, and the reason you do that is if I had a triangle and I had 8, 12, and 4, when I added 8 and 4, would that be bigger than 12? No. So x has to be bigger than 4. That's why we do the subtraction, so you know what it has to be bigger than, but also what it has to be less than. So for number 8, you would do that same thing. We would do 11 plus 4 would give me what it has to be less than, so 15. And then you would subtract the 2 to see what it'd have to be bigger than, which would be 7. Does that make sense? Okay.